Testing. Math 0092. We're going to begin with Chapter 2, Section 1. And in doing so, we're talking about factorizations. Now, to factor a number, we look for a product. So when we factor, we are determining a product, A times B. And A and B are called factors. If we divide Q by D and get a remainder of 0, then the divisor D is a factor of the dividend Q. So we're supposed to determine if the following are factors of each of these numbers. So we have 6 goes into 198 33 times with a 0 remainder. So yes, since the remainder is 0, 6 goes into 198 evenly, and 6 is a factor of 198. And we know that because we check 6 times 33 is 198. And then we check to see if 15 is a factor of 198. 15 goes into 198, but there is a remainder of 3. So since the remainder is not 0, 15 does not go into 198 evenly. On page 87, we're supposed to list all the factors of 70. List all the factors of 70. So a good way to do that is to list your number 70. And we can break it down. We want to factor as 1 times 70. Those are 2 factors. We have 2 times 35, which is 70. We have 5 times 14, which is 70. 7 times 10, which is 70. So listing the factors of 70, we have 1, 2, 5, 7, 10, 14, 35, and 70 itself. We're asked to find factors of 62, and we can do the same thing. 1 times 62. 62 is even, so 2 times 31. 2 times 31 would be 62. And doesn't look like there's any more factors of 62. So listing the factors of 62, we're going to get 1, 2, 31, and 62. Our next topic is divisibility on page 88. The number A is divisible by another number B if there exists a number C such that A equals B times C. The statement A is divisible by B, A is a multiple of B, and B is a factor of A all have the same meaning. Thus, 27 is divisible by 3 because 27 equals 3 times 9. We can also say that 27 is a multiple of 3, and we can say 3 is a factor of 27. So we're to determine whether 45 is divisible by 9. Well, 45 is divisible by 9 because 5 times 9 is 45 with a remainder of 0. So yes, 45 is divisible by 9. We're to divide 45 by 4. Goes once, 4, on the 5, once, 4, once. We have a remainder of 1. Since we have a remainder other than 0, 45 does not go into 4 does not go into 45 evenly. If you're going to check on your calculator, 45 divided by 4 is 11 point. As long as there's a decimal point with some numbers, that means your remainder. If it's 11.00, well then we're expecting that to be a whole number. Anything following the decimal point is your decimal fraction. So no, 45 is not divisible by 4. Prime and composite numbers. A natural number that is exactly two different factors, that is only itself and 1, is called a prime number. The number 1 is not prime, obviously 1 times 1 times 1 times 1 times 1. The natural number other than 1 that is not prime is called composite. So prime numbers. 2. Well, 2 has 1 times itself, and those are the only factors, so yes, it's prime. 3 has 1 times 3, only those two factors, so yes, it's prime. 4, oh dear, we have 1 and 2 times 2 and 4, the number itself. So there's factors other than 1 and the number itself. So no, 4 is not prime. 5, the factors are 1 and 5, so yes, it's prime. 6, well, 6 is even, so we know it has 1 and 6 and 2 and 3 in this case. So it has factors other than 1 and itself, so no, it is not prime. 7 is an example of a prime number, 1 and itself. 8 is 1 and 8, but it's even, so it has 2 as a factor, so no, it's not prime. 9 has 1 and 9, but also 3, so no, it is not prime. 10 is even, so it has itself and 1, but it also has 2 and 5, so no. 11 is an example of a prime number. 1 and 11 are the only factors. Yes, and so on. Prime numbers are very interesting. Prime numbers are any natural numbers. That's 1, 2, 3, 4, 5, 6, and so on. Recently, a new prime number was found. It's a very large number, and you can check on the internet for information about a recent found and identified prime number. When we factor composite numbers into a product of primes, we find the prime factorization. So we may want to find the prime factorization of 39. Well, we look for a number that will go into 39 evenly. 3 does. That'd be 1, 3, bring down the 9, 3. So 3 times 13 is 39. 3 is prime and 13 is prime. So the prime factorization of 39 is 3 times 13. All factors must be prime for the prime factorization. We're supposed to find the prime factorization of 220. Well, a good way to start, it is even, so let's take 2 into 220. That'll be 110. 110 is still even, so let's take 2 into 110. And that'll be 55. 55, we know 5 will go into that 11 times. 2 is prime, 2 is prime, 5 is prime, and now we know 11 is prime. So the prime factorization of 222 is the prime numbers 2 times 2 times 5 times 11. And that'll equal 222. 220. On page 90, a statement is an important one. Every number has just one unique prime factorization. So as you're working with your prime factors, there's only one prime factorization for every natural number. Now another way to find the prime factorization is to use a factor tree. So if we're supposed to find the prime factorization of 72, we can factor that as 2 times 36. 2 is prime, so I'm just going to carry that down, but now the two factors of 36 are 2 times 18. 2 is prime, I'll carry it down. 2 is prime, I'll carry it down, but we can factor 18, I know, because it's even. So it has 2 as a factor other than 1 in itself. It's 2 times 9. 2 is prime, I'll carry it down. 2 is prime. 2 is prime, I'll carry it down, but 9 can be factored as 3 times 3. So my prime factorization is 2 times 2 times 2 times 3 times 3. The prime factorization of 72. Another example using the factor tree, 189. Well, let's see, 3 goes into that. 3 times 60. 3 is prime, I'll carry it down, but 63 can be factored as 7 times 9. 3 is prime, I'll carry it down. 7 is prime, I'll carry it down, but I can factor 9 as 3 times 3. So the prime factorization of 189 is 3 times 3 times 3 times 7 equals 189. All factors must be prime factors to represent the unique prime factorization of a number. In section 2.2, we talk about rules for divisibility. And we'd like to know if a number is divisible by 2. A number is divisible by 2, that is, it is even, if it has a ones digit of 0, 2, 4, 6, or 8. That is, it has an even ones digit. So let's look at 355. Is it even? Divisible by 2. So we look at the ones unit, and it is not an even number, 0, 2, 4, 6, 8. So no. 4,786. We look at the ones digit. Divisibility by 2, it must be even. So yes, it is divisible by 2. 8990. We look at the ones digit, and 0 is an even digit. 0, 2, 4, 6, 8. This number is even. It is divisible by 2. And another test, 4, 2, 6, 1. Look at the ones unit. Is it an even digit? No. So it is not evenly divisible by 2. Divisibility by 3. A number is divisible by 3 if the sum of its digits is divisible by 3. So we look at examples. Our first example is 18. Now, to determine if it's divisible by 3, I add the digits. I get 1 plus 8 is 9. 9 is divisible by 3, so yes, 18 is divisible by 3. 93. 9 plus 3 is 12, so yes, it's divisible by 3. 201. 201. 2 plus 0 plus 1 is 3, and 3 is divisible by 3, so yes. I'm adding the digits. If the addition of the digits is divisible by 3, then the number is divisible by 3. Then 256. 256, adding the digits, I get 2 plus 5 is 7 plus 6 is 13, and 13 is not divisible by 3, so no, 256 is not divisible by 3. Divisibility by 9. Divisibility by 9. A number is divisible by 9 if the sum of its digits is divisible by 9. So 6, 9, 8, 4. 15, 23, 27. The sum of the digits is 27. 27 is divisible by 9. So yes, 6,984 is divisible by 9. 322. The sum of the digits is 5, 6, 7. 7 is not divisible by 9, so no, it is not divisible by 9. You can check for divisibility of a number if the sum of its digits is divisible by 9. Divisibility by 10. A number is divisible by 10 if the ones digit is 0. 3,440. Well, here's my ones digit, and it is 0, so yes, it's divisible by 10. 3,447, check the ones digit. If it's a 0, it's divisible by 10. If it's not, it is not divisible by 10. Divisibility, a number is divisible by 10 if its ones digit is 0. And divisibility by 5. A number is divisible by 5 if its ones digit is a 0 or a 5. 220, check the ones digit. Is it a 0 or a 5? Yes. So 220 is evenly divisible by 5. 475, the ones digit is a 5 or a 0, so yes, it's divisible by 5. And 6,514, check the ones unit. If it's 0 or 5, it's divisible by 5. Otherwise, it is not divisible by 5. Section 2.3. We're going to begin to discuss fractions. Numbers like 2/3, 4/7, 5/8 are called fractions. They're called fractions because they're in fractional notation at the format, fractional notation with a numerator over a denominator. So fractional notation is a number with a numerator and a denominator. Example 2 on page 100, we begin to look at fractions of a whole diagram. And this diagram has been divided into eighths. Here's 1/8, here's an eighth, here's an eighth, and some of them have been treated. So the equal parts are 1/8, 1/8, 1/8, 1/8, and there's actually 8 equal parts. The denominator of 1/8 is in the bottom, down below, and the numerator is on top. The denominator is down. The denominator is in the down position. And if we look at the equal shaded parts of this diagram, we have 1/8 plus 2/8 plus 3/8 plus 4/8 plus 5/8. So there are 5/8 shaded in this diagram. In the next diagram, what part is shaded? Now this whole diagram, we have 1, 2, 3, 4, 5, 6 with 3 rows, each of 6 units. So 3 times 6 is 18. So we have 18 equal parts. Each part is 1/18. And the shaded part is 1, 2, 3, 4, 5, 6, 7. So we have 7/18 shaded. On page 100, example 4, what part of an inch is indicated? Well, here we see our ruler, and there's up to 1 inch right here. And we've marked off or half off 16 equal spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16 at 1 inch. So there's 16 equal parts identified within this 1 inch. And then we've measured off how many parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 11. So we've measured 11/16 of an inch. The next diagram on page 101 is interesting. Example 5. We have an object shaded. It has 1, 2, 3, 4, 5, 6, 7, 8 equal parts in each row of 3. So 3 times 8 is 24 equal parts. So each unit is 1/24. The denominator is 24, the numerator is 1. We want to know what part is shaded. Well, everything is shaded. So that's 24 units out of 24 units is shaded. And we know that that is another name for 1. The entire object is shaded. So one object is shaded. 24 units out of 24. Be careful with the next one. Step B of question example 5. We have equal parts. This is not one whole diagram. These are 3 separate parts. And we have 1, 2, 3, 4, 5, 6 equal parts. So it's divided into 6 equal parts. So we're working with 1/6 to represent a part. Now we want to determine how many parts are shaded. Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 of 6 equal parts shaded. In the ice cream roll-up cake, what part of an ice cream roll-up cake is dark brown? Well, we've kind of shaded. We have 3 roll-up cakes. They're sliced into 1, 2, 3, 4, 5, 6 slices each. So we have 6 equal slices. So each unit is 1/6. The denominator is 6, the numerator is 1. And now looking at the shaded parts, might be a little bit hard for you to tell, but the first roll is shaded, the second roll is darkened, and then the first equal part of the third ice cream cake is shaded. So this section is shaded compared to the last 5 slices. So we have 6 shaded plus 6 shaded plus 1 more would be 12 plus 13. So we have 13 equal parts of 6 shaded. Our next topic is the ratio. A ratio is a quotient of two quantities. Now remember that a quotient is when we divide. The ratio of a quotient. Quotient is our result when we divide. For example, 8 on page 102, baseball standings. The following table shows the final standings in the American League Central for 2016 when the Cleveland Indians won the division. Find the Indians' ratio of wins to losses, wins to total games, and losses to total games. So here's our chart. The Cleveland Indians win and lose, and the total number of games would be the addition of the 94 wins and the 67 losses. So we have a total of 161 games played. Now, first we would like to find the Cleveland Indians ratio of wins to losses. So we set up a quotient, wins to losses, and the ratio for Cleveland Indians of wins to losses is wins is 94 and their losses was 67. Next, we're asked to find the ratio of wins to total games. So we're going to look at the chart for Cleveland Indians and wins to total. Well, their wins was 94, and the total number of games played was 161. And we're supposed to find the ratio of losses to total games. Losses to total games. The Cleveland Indians losses was 67 to the total games played was 161. So that's how we represent ratios as a quotient of two numbers. A special case is when we have a number of 1 in fraction notation. Any number, n over n, is equal to 1, as long as we're not dividing by 0. Division by 0 is undefined. So n over n is another name for 1. N over n is in fractional form. We have a numerator and a denominator. So 5 over 5 is another name for 1. 13 over 13 is another name for 1. And it's important for us to remember this because we use this strategy as we begin to solve problems. So 24 over 24 is another name for 1. On page 106, we are in question number 35. For the following set of animals, what is the ratio of puppies to total number of animals? So reading my question, I get my ratio. We're looking at the ratio of puppies to total number. All right, puppies to total. Well, the puppies in the diagram, I have 1, 2, 3, 4, 5 puppies. I have 5 puppies, and the total in the diagram, total number of animals is 1, 2, 3, 4, 5, 6, 7. So my ratio of puppies to the total number of animals is 5 to 7. Next, we're asked for puppies to kittens. So I'm going to write puppies to kittens. That'll be my ratio. I know already that there's 5 puppies. How many kittens? 1, 2. So the ratio of puppies to kittens is 5 to 2. Next, we're asked to find kittens to the total number of animals. I'm going to write my ratio, kittens to total number of animals. Kittens to total number. Well, the kittens, once again, is 1, 2. And my total, 1, 2, 3, 4, 5, 6, 7. So the ratio of kittens to total is 2 to 7. And finally, kittens to puppies. Find the ratio of kittens to puppies. Kittens to puppies, 1, 2, 3, 4, 5. So the ratio of kittens to puppies is 2 to 5. Next is section 2.4. And we're on page 109. And we're going to use multiplication with fractional notation. So when I multiply fractions, 9 sevenths, I have a numerator and a denominator, times 3/4, I have a numerator and a denominator, so I have a fraction times a fraction. Multiplication of fractions is a piece of cake. So maybe you had problems with multiplying fractions in the past. Let me show you. Multiplication. There's our cake right there. It's a piece of cake. You multiply the numerators, 9 times 27, multiply the denominators. And then can we simplify? No, so our answer is 27/28. Multiplication of fractions, 5/6 times 7/4. I have a fraction times a fraction. Multiplication of fractions is a piece of cake. Multiply the numerators, 5 times 7 is 35. 6 times 4, multiply the denominators is 24. No number goes into the numerator and the denominator evenly to simplify, so circle your answer. 3/5 times 7/8. Multiplication of fractions, so I'm multiplying fractions. Multiply the numerator, 21. Multiply the denominators, and simplify if you can. There's no number that goes into 21 and 40 evenly. Multiplication of fractions, piece of cake. Multiply the numerators, multiply the denominators, simplify, see if there's a number that goes into the numerator and the denominator evenly. page 111, we have an application problem to solve. A real estate developer owns a plot of land and plans to use 4/5 of the plot for a small strip mall and parking lot. Of this, 2/3 will be needed for the parking lot. What part of the plot will be used for parking? Well, here we have 4/5 of the area, and we want to make room for 2/3 will be needed for the parking lot. So 2/3 of the 4/5 area will be needed for parking. So if we let n equal the part of the plot that's going to be used for parking, we are taking 2/3 of the original 4/5. The word of corresponds to multiplication. So 2/3 times 4/5 is going to equal our parking area. 2/3 of the total parcel of 4/5 will equal our parking lot. Multiplication of fractions, of represents multiplication. So now I have 2 times 4 is 8 in the numerator, and multiply the denominators, 15. So 8/15 will be the parking lot area that takes up the plot of land. Example 8 on page 112. The area of a cranberry bog. The length of a rectangular cranberry bog is 9/16 of a mile. The width is 3/8 mile. What is the area of the bog? Well, first of all, we have to kind of sketch our diagram. We have this rectangular bog, 3/8 mile wide and 9/16 mile long. And since it's rectangular, we remember that the area of a rectangular object is the length times width. So setting this up, the area of this rectangular cranberry bog is the length, 9/16 mile, times the width, which is 3/8 mile. We remember that our commutative law for multiplication, that terms can commute as long as it's all multiplication. 3 times 4 is the same as 4 times 3. The terms can move around. 9/16 times 3/8. We'll collect our numbers together, and then we'll get our units together. Area is equal to multiplication of fractions of a piece of cake, multiply the numerators, multiply the denominators, and 16 times 8 is 128. And miles times miles is miles squared. So the area is 27 over 128 square miles. Then example 9 on page 112. A recipe for oatmeal chocolate chip cookies calls for 3/4 cup of brown sugar. Monica is making 1/2 of the recipe. How much brown sugar should she use? So we're looking at 1/2 of the recipe. So we have 1/2 of, which stands for multiplication, for 3/4 cup, equals the amount she will use. So 1/2 of the recipe, 1/2 of the recipe. So 1/2 of the recipe is 3/4 cup for brown sugar. Again, it's multiplication of fractions. Multiplication of fractions is a piece of cake. Multiply the numerators. Multiply the denominators. And 1 times 3 is 3. So we have 3/8 cup of brown sugar needed when she calculates 1/2 of the original recipe. And section 2.5 begins on page 115. Multiplication or multiplicative identity for fractions. When we multiply a number by 1, we get the same number. We've talked about this before. 8 times 1 equals 1 times 8, which equals the number. 7 times 1 equals 1 times 7. Any number times 1 is a multiplicative identity. 1 times any number is the number itself. So 8 times 1 equals 1 times 8 with our multiplicative law for commutative law of multiplication. Terms can commute, they can move around, still equal to 8. Any number times 1 is equal to the number itself. Now we want to suppose that we want to find another name for 2/3. But we know we want the denominator to be 9. So what would an equivalent number look like? 2/3 is equal to how many 9s? So we're going to have to find a number times 3 that equals 9. Well, 3 times 3 is 9. But if I multiply the denominator by 3 to make it a 9, I'm going to have to multiply the numerator by 3. Because now I have another name for 1. And 1 times any number is the number itself. In fractions, it may not look the same, but it has the same value. So 3 times 2 is 6, and 3 times 3 is 9. So 2/3 is equal to 6/9. Let's try another one. I have 2/5, and I want to make it equivalent in 35. So I need to have a denominator of 35, but I only have 2/5 right now. So 5 times what would give me 35? Well, that would be 7. But if I multiply the denominator by 7, I'll have to multiply the numerator by 7 as another name for 1. 1 times a number is the number itself. But in fractions, it may look different, but it has the same value. So 1 times 2/5 is the same value. 7 times 2 is 14, and 7 times 5 is 35. So 2/5 is equal to 14/35. Another example, I have 1/4 and I need to have a denominator of 24 as I'm working and solving problems. So I want an equivalent of 1/4 in 24. Well, 4 times 6 would be 24. But if I multiply the denominator by 6, I'll need to multiply the numerator by 6. There's another name for 1. 6 times 1 is 6, and 6 times 4 is 24. So 1/4 is equal to 6/24. We're sometimes asked to simplify because we want to look for the smallest numerator and the smallest denominator. That is, the numerator and the denominator have no common factors other than 1. So to simplify, 8/20. Simplifying, I want to look for a common factor. Both are even, so I can divide the numerator and the denominator by 2. 2 goes into 8 4 times, and 2 goes into 20 10 times. But it looks like I can divide by 2 again. 2 goes into 4 twice, and 2 goes into 10 5 times. And now both of these are prime, so I have my simplified answer. 2 6. Well, both are even, so I know I can divide both the numerator and the denominator by 2. 2 goes into 2 once, and 2 goes into 6 3 times. Simplified, 3 is prime. I cannot reduce that any further. I'm supposed to simplify 90 over 84. Well, I see that both are even, but they're large even numbers, so 2 times I'd be dividing by 2 maybe multiple times. So I can factor. And just choose to factor 90 as 9 times 10. And choose to factor 84 as 4 times 1. Kind of mental math. I'm continuing to prime factor, looking for other names for 1. So I'm going to factor 9 as 3 times 3, and I can factor 5 as 2 times 5. Factoring 4, I get 2 times 2, and factoring 21, I get 3 times 7. That's a prime factor now. They're all prime factors. I'm going to look for other names for 1. Remember that 1 is identity property for multiplication. So this has to be all multiplication in the numerator and the denominator. And now I can reorder this. The numerator, 2 times 3 times 3 times 5. In the denominator, I have 2 times 2 times 3 times 7. And I'm looking for other names for 1 to simplify. Here's another name for 1, 2 over 2. And here's another name for 1, 3 over 3. 1 times any number is the number itself. What do I have left? 3 times 5 in the numerator and 2 times 7 in the denominator. 3 times 5 is 15 and 2 times 7 is 14. I cannot simplify that any further. You can circle your answer. Your directions might say simplify. We have 603 divided by 207. Well, I'm using my divisibility test. And that's from chapter 2, section 2. And let's see, 6 plus 3, that'd be divisible by 9. And 2 plus 7 would be divisible by 9. So I know that 603 over 207 is equal to 9 times something. So 603 divided by 9 is 67. 9 times 67 is 603, and 207 divided by 9 is 23. It's all multiplication, and I have a factor of 9 over 9, which is another name for 1. So what's left? 67 over 23. And both are prime, so cannot be simplified any further. We test for an inequality. Two fractions are equal if their cross products are equal. 3 over 6, and we're testing. 2 over 4. We call 3 times 4 and 6 times 2 cross products. Cross product, 3 times 4 and 2 times 6. Since the cross products are the same, that is 3 times 4 equals 6 times 2, we know that 3 6 is equal to 2 4. So let's check. We have 6/7, and we want to know, is 6/7 equal to 7/8? Well, we can check with the cross product. 6 times 8 is 48. 6 times 7 times 7 is 49. So, no. We multiply these two numbers, and they do not equal. So 6/7 is not equal to 7/8. And you'd probably write this. The filling in the text box is not equal to. Let's try another one. 6/10, 3/5. The cross products. 6 times 5 is 30, and 3 times 10 is 30. So 6/10 is equal to 3/5. The cross products. Cross multiply. If they are equal, then your two terms are equal. If they're not, then your terms are not equal. On page 121, we're looking at exam questions 49, 50, 51, and 52, and we're looking at the chart. And we have taco filling preferences. Chicken is 1,600, fish is 1,700, beef, veggie, and pork. And we're supposed to simplify the fraction associated with each reference. So we're looking at the chicken filling for number 49. So I'm going to check out the chart and find the chicken filling reference, which is 16/100. And I want to simplify. Well, I see that 2 goes into both, they're even, but I also see that 4 goes into 16, and I know 4 goes into 100 evenly. 4 goes into 16 4 times, and 4 goes into 125 times. I simplified the chicken filling. Item 50, we're supposed to look at the veggie filling and simplify it. Well, the veggie reference is, I'm looking at my chart, and I'm finding the veggie reference at 4/100. Again, 4 goes into 4 and 100 evenly, so 4 goes into 4 once, and 4 goes into 125 times. It's simplified. 51, I'm supposed to look at the beef filling reference, and the beef filling reference is 48/100. Both are even, so I know 2 will go into both. 4 actually goes into 48 and 100, so 4 goes into 48 12 times. 4 goes into 125. The numerator is even, the denominator is odd, so that's simple. 52, I'm supposed to simplify the pork filling reference. Looking at my chart, I want to find the pork reference, which is 15/100. Now I know from my divisibility test for 5, divide by 5, if the 1 position is a 5 or a 0, it's divisible by 5. So I'm going to divide the numerator by 5 and get 3, and divide the denominator by 5 and get 20. 3 does not go into 20, so it's simplified. I use my divisibility rules to assist in simplifying the preferred filling reference with respect to my chart. Page 123, there's a story problem. College acceptance. For the year 2016-17 school year, Stanford University top schools receiving the highest number of applications with 43,997. For every 25 applications, only 6 students were accepted. What was the ratio of students accepted to applications received? So for every 25 applications, only 6 students were accepted. We're looking for the ratio of students accepted to applications received. Well, students accepted were 6 out of every 25 applications. So the ratio of students accepted to applications is 6 to 25, and I cannot simplify that any further. And also on page 123, number 40, the area of an ice skating rink. The length of a rectangular ice skating rink in the atrium of a shopping mall is 7/100 of a mile. The width is 3/100 of a mile. What is the area of the rink? Well, it is a rectangular rink, so we can label that as 3/100 of a mile width and 7/100 of a mile length. We know the area of a rectangular object is the length times the width, so I can substitute. The length in my case is 7/100 of a mile, times the width in my case is 3/100 of a mile. I know this is all multiplication, so I can let my terms commute. I'll get my constants together and get my units together. The area of this rectangular ice skating rink, multiplication of fractions, a piece of cake, multiply the numerators, multiply the denominators, and miles times miles is square miles, or miles squared with your exponent. And 21, there's no number that go into both of these evenly, so you can circle your answer. So that takes us through section 1.5 and a couple of problems in the mid-chapter review. I would suggest that you study and do as many problems as necessary in the mid-chapter review on page 122 and 123 in your ebook to review this entire section. And then, of course, return to D2L Brightspace, our homepage for all details regarding homework, assignments, tests, and due dates. And thank you very much.